This is Unit 7, Electrons, Part 1 Notes. By the end of this unit, you should be able to express the arrangement of electrons in atoms and ions based on Lewis valence electron dot structures by using the octet rule and explain how it influences chemical reactivity. Also, you need to know the exceptions to the octet rule, which is the duet rule. As previously lectured over, valence electrons are electrons in the highest occupied energy level of an element's atom. They are identified by the group number for the A representative groups, and on a periodic table, those are the first two columns, and then groups 3 through 8. So those are the only representative groups. Everything else, those are your transition metals, and that is not considered the A group. Those are your B groups. And the valence electron number that establishes chemical reactivity because they act in a similar way that is due to the number of valence electrons. And just to review the groups, 3, 4, 5, 6, 7, 8. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 3 would have 3. Group 4 has 4. All the way until group 8 has 8 valence electrons. That you should already know. So now we can represent those valence electrons by using what is known as Lewis dot structures. Lewis dot structures represent the valence electrons in a symbol form. The rules that we need to follow are that only one dot can be added per side at a time. So if you think of these elements like a box, you have 4 sides, and only one electron can be added to one side at a time before we go back and pair up those electrons to get a total of 8. Because that octet rule, every element wants 8 valence electrons in their valence shell so that they are completely filled, they're unreactive, and they mimic a noble gas. So if we look on period number 3, just to review, periods go left to right. So in period 3, we have sodium all the way through argon. Sodium is in group number 1, so it's going to have 1 valence electron. That's one circle. Magnesium is in group number 2, so it's going to have 2 valence electrons. And again, we're following the rule where we can only add in, that's a terrible circle, only add in 1 electron at a time. So that's 2. Aluminum is in group number 3, so it's going to have 1, 2, 3 valence electrons. Silicon is in group number 4, so it's going to have 4. 1, 2, 3, 4. So those are your valence electrons. I'm trying to make them a little bit more clear. So that would be the Lewis dot structure of neutral silicon. Now we're going to go on to groups 5 through 8. So the same rules apply. Only one dot can be added per side at a time. So we have 1, 2, 3, 4. So now we have to add in one more, so then that's where the pairs are going to start happening. So now we have a total of 5. So you have 2 electrons on one side, and then 1, 2, 3 singles on the other sides. Going to sulfur, that's in group number 6. So then we'll start at 1, 2, 3, 4. Oh, those are terrible circles. 4. Then we go back and add 5, 6. So we should have 2 electrons on 2 sides, and then singles on the other 2 sides. Chlorine is in group number 7, so it's going to have 7. So that's 1, 2, 3, 4, 5, 6, 7. Now there are 3 sides of pairs and only one side that has a single electron. And then, obviously, group number 8, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So now we have 4 sides with 2 electrons, so we have a total of 4 different pairs. Later on, when we start going into bonding, there's a big difference between the side that has pairs and then the side that doesn't have a pair. And then we will get into detail when that lecture comes, which is going to be in Unit 8. But please be aware that you have sides that can either have pairs of electrons or can have a single electron, and that depends on following the rules for writing in your Lewis dot structures. And these are all of neutral elements. Okay, so just to recap, your main groups 1, 2, 3, 4, 5, 6, 7, 8. Those are your main elements. The group number is going to represent the number of valence electrons. We had the octet rule where every element on the periodic table wants 8 around itself whenever they form ions. There's the exception. Hydrogen and helium follow the duet rule because they're on the first period, which is only one ring around the nucleus and only 2 electrons. Those are electrons. 2 electrons can fit on that first ring. Once those are filled up, we have to add in that second level, and then that's where the 8 rule or the octet rule comes into play. And then as you can see, every element in the same group is going to have the same sort of Lewis dot structure. So every element in group 1 is going to have 1 dot. Every element in group number 2 is going to have 2 dots to represent the valence electrons. Group 3 elements are going to look the same. Group 4, 5, all the way across, except for helium. Remember, that's the duet rule. It only can have a maximum of 2 electrons, and they are going to be paired up together. So we've already learned how to write Lewis dot structures of neutral elements, but now we need to learn how to write Lewis dot structures of your ions. So again, ions, just to review the definition, it's about the 3rd time we've been writing these notes in our ISNs. Ions are formed by losing or gaining electrons. If you lose electrons, you form positive charges. Those are your cations. And if you gain electrons, they form negative charges, or your known as anions. We can use the Lewis dot structure to show that ion formation. So then we have to add in those charges. So if we need to climb our mountain, +1, +2, +3, plus or minus 4, -3, -2, -1. And that mountain, if you want to use that instead, you write in your A for +1, +2, +3, plus or minus 4, -3, -2, -1. And those represent the first 7 groups because group number 8, they don't form charges. So looking at sodium. Sodium is in group number 1, so normally it would have 1 dot for its Lewis dot structure. But sodium in group number 1, they normally form +1 charges. If you form a plus charge, that means you lost an electron. If it forms a +1, it literally loses that electron, so you take it off and erase it to show that +1, and it's lost that 1 single valence electron. So you're literally losing that electron to form the +1 charge. Sulfur is in group number 6, so it's going to have 1, 2, 3, 4, 5, 6 valence electrons. Group 6, 2, 3, 4, 5, 6. Group 6 normally forms a -2 charge. If you form a negative charge, that means you've gained electrons. If it forms a -2, it's gained 2 electrons, and it's going to gain them on the sides that are not paired up together to complete that octet. So now sulfur gained 2 electrons, and then we notate the charge in the upper right-hand corner as a -2. So now chlorine's in group number 7, so it's going to normally have 1, 2, 3, 4, 5, 6, 7 valence electrons. It gained 1 electron to form a -1 charge, and it's going to gain it on the side that's unpaired, and then we add in that charge in the upper right-hand corner. Magnesium is in group number 2, so it normally has 1, 2 valence electrons. However, group 2 charges group 2, they form +2 charges. That's a cation. That means it lost those 2 electrons. So you literally erase them and show that the magnesium lost those 2 electrons to form that +2 charge. So if you look at the examples that we've already done, cations, whenever they form those charges, they do not have any electrons, valence electrons on their shell. That's because they've lost the outer ring and they're mimicking the noble gas in the row above them. However, if you look at the anions, they're going to show the full valence shell. So those are going to actually show full valence shell, and they're going to mimic the noble gas right after that. So it's going to be on the noble gas of the same period. The cations are going to mimic the noble gas on the previous period. And that's something to understand, that we don't see the full valence shell of the cations. That's because they are mimicking the noble gas on the period above it, so that outer shell has been lost. Anions just completely fill up the shell that they're already on. That's why we see those full 8 electrons around their shell. Okay, so what I want you guys to do now is to practice trying to identify valence electrons and charges, and then drawing Lewis dot structures. So press the pause button, write these examples down, try to do them, then go back and check yourself. The first set, we're going to identify the valence electrons for the following elements. Okay, so valence electrons are equal to the group number. Potassium is in group number 1, so it's going to have 1 valence electron. Boron is in group number 3, so it's going to have 3 valence electrons. Chlorine is in group number 7, or 7A, those are your halogens, so it's going to have 7 valence electrons. Step number 2, we're going to write the Lewis dot structures of the neutral elements. Okay, that's based on the number of valence electrons. So if potassium has 1 valence electron, I'm going to use the green color, it's going to have 1 dot. Boron is in group 3, so it's going to have 1, 2, 3 dots. And I'm only going to be using the green for that one, so you can see those. Chlorine, I'm going to use a different color. It's going to have 7 because it's in group number 7. So we have 1, 2, 3, 4, 5, 6, 7. So we have 1, 2, 3 pairs, and then that 1 single on top. Please don't think that the black dot, just show the bullets of those examples, are part of those valence electrons as well. Okay, so potassium's in group number 1, 1 dot. Boron's in group 3, 3 dots. Chlorine's in group 7, it has 7 dots. Then we need to form the ions of those elements. Potassium, because it's in group number 1, if you want to climb your mountain, that's of the main A group. Potassium's in group number 1, it'll form a +1 charge. Boron, since it's in group 3, it's going to form a +3 charge. Chlorine is in group number 7, it'll form a -1 charge. And then now we need to identify, or write in the Lewis dot structure. So because potassium had that 1 valence electron, since it forms a +1, it's going to lose that electron, so it will not have any dots around its structure. Boron is a +3, so those 3 electrons, it had to lose those electrons. So we write the charge in the upper right-hand corner, showing that the Lewis dot structure transitioned from the neutral boron atom to the charged atom. And then chlorine, it had 7 valence electrons. It forms a -1 charge. So it's going to gain 1, 2, 3, 4, 5, 6, 7. It's going to gain that last electron, filling that shell, and then we write in the charge in the upper right-hand corner. Okay, so are you able to express the arrangement of electrons and atoms and ions based on Lewis dot structures? Are you able to also explain the octet rule or the duet rule? If you're not, you should probably restart the video, watch it again, highlight areas that you need to have questions answered, and then ask me the next time we talk about this in class.